In this video, I'm going to go through the solutions to Unit 1 test. The first question is we have to find the state, the domain range, and also explain if the following represent a function or relation and the reason. The first thing we have to notice is that none of the graph in A does not have any arrows, so it means that the graph starts at this point and it goes to this point. So from here to here. This means that the domain is x in R and x is less than or equal to, if you look here, this is 2 and is greater than or equal to here, which is going to be, remember, the origin is here, so it's going to be -6. Now the y values for range, they are in R and they start from this point, which is going to be 5. So y is less than or equal to 5 and greater than or equal to this point, which is going to be -2. Now the next question is that is it a function or not? The answer is no, because it doesn't pass the vertical line test, since if I draw a line which goes like this one, although the line has to be perpendicular, meaning something like this one, it crosses the graph in 2 points. So this is just a relation, because it does not pass the vertical line test. The next question is this parabola. Since we have the arrows here, then it means that the graph continues to infinity here. So our domain is x in R, and x has to be greater than or equal to this point here, and this point is -4. So x is greater than or equal to -4, and our range is going to be just R, because it goes to infinity from here and it goes to infinity from here. So y in R. Now the next question is that is it a function or relation? It is obvious that this is not a function, since if I draw a vertical line like this one, it crosses the graph at 2 points. So again, this one is a relation, not a function. The next question is we have given two functions g and h, and we are supposed to find some values. The first one is g minus 3. G minus 3 is going to be the function with x replaced with -3, so it's -3 minus 2 times -3, which is going to give us -6 over -3 plus 6, which is -6 over 3, which is going to give us -2. The next one is h minus 10. So h minus 10 is equal to 4 times -10. Replace x with -10. So -10 minus 5 minus 1, which is going to give us, if we simplify this one, is -40 times -15 minus 1, which is going to be negative or positive 599. The next question is to complete the square for the following function. We are not supposed to use any decimals, and the function is 3x squared minus 5x minus 4. We know that to complete the square, the leading coefficient has to be 1, so I'm going to factor 3 from the first two terms. So I'm going to get 3x squared minus 5 over 3x minus 4. Now I'm going to divide the 5 over 3 by 2 and then square it. So 5 over 3 divided by 2 over 1 is the same as 5 over 3 times 1 over 2, which is 5 over 6. Now 5 over 6 squared is 25 over 36, so this becomes 3x squared minus 5 over 3x plus 25 over 36 minus 25 over 36 and then minus 4. Remember, the addition of these last two terms is equal to 0, so nothing has been changed. But now if I put a bracket around the first three terms, this is a perfect square, so I can write it as 3x minus 5 over 6 squared minus 25 over 36 minus 4. Now distribute 3 inside the bracket, we get 3 times x minus 5 over 6 squared minus, now 3 times 25 over 36 is going to give me 25 over 12 minus 4, which is 3 times x minus 5 over 6 squared. Now 4 is the same as 4 over 48 over 12, so I can write this one as negative 25 over 12 minus, multiply by 12 divided by 12, you get minus 48 over 12, which is the same as 3 times x minus 5 over 6 squared. Minus 25 minus 48 is going to give us minus 73 over 12. The next question says, write the equation for the family of quadratic functions with their following zeros. Negative 3 plus or minus square root of 5. So the family of quadratic becomes y is equal to a times x minus the first root. So it's going to be x minus 3 plus square root of 5 times x minus 3 minus square root of 5, which is equal to a times x. If you distribute negative inside, you get plus 3 minus square root of 5. Again, if you distribute negative inside, we get x plus 3 plus square root of 5. Now, to expand this one, you can either expand term by term, or easier than that one, if I put a bracket around these two, if this is a, this becomes a. If this is b, this is b. So we have a plus b times a minus b. We know that this becomes a squared minus b squared. So this is the same as a, open bracket, x plus 3 squared minus square root of 5 squared is 5. Now if I expand this one, I get x squared plus 6x plus 9 minus 5, which is the same as a times x squared plus 6x plus 4. Since I have to make it in standard form, I'm going to distribute a inside. I get ax squared plus 6ax plus 4a. The next question says, find the equation of the function that has zeros 1 plus or minus square root of 11 and goes through the point 4 and negative 6. We are supposed to express the function in standard form. The function becomes y is equal to a times x minus 1 plus square root of 11 and x minus 1 minus square root of 11, which is the same as a x minus 1 minus square root of 11 times x minus 1 plus square root of 11. I am just distributing negative inside. Now if we look at these two brackets, if I put another bracket here and one here, then I get a minus b times a plus b, which is a squared minus b squared. So this is exactly like a times x minus 1 squared minus 11. Now, before I expand this one, I'm going to use the point given here. It says that when x is 4, y is negative 6. So y negative 6 is equal to a times x is 4. So 4 minus 1 squared minus 11, which is a. 4 minus 1 is 3 squared is 9. So 9 minus 11, which is going to give us negative 2a. Negative 2a is negative 6. I divide by negative 2 both sides. I get a is equal to 3. So the equation becomes y is equal to 3 times x minus 1 squared minus 11, which is the same as 3 x squared minus 2x plus 1 minus 11, which is 3 times x squared minus 2x minus 10. Now I distribute 3 inside. I get y is equal to 3x squared minus 6x minus 30. The next question is to simplify the following expression. The first one is 2 square root of 3 times square root of 6 minus 2. I can write this one as 2 square root of 18 minus 4 square root of 3, but 18 is 2 square root of 9 times square root of 2. 9 times 2 is 18 minus 4 square root of 3. So the answer, square root of 9 is 3, so it's going to be 6 square root of 2 minus 4 square root of 3. The next one is negative 5 square root of 45 over square root of 36. I can write this one as negative 5 square root of 9 times square root of 5, since 9 times 5 is 45, divided by square root of 36 is 6. So this becomes square root of 9 is 3, so it's negative 15 square root of 5 over 6. But since 15 and 6, they are divisible by 3, I get negative 5 square root of 5 over 2. The next one is 1 over 2 square root of 8 plus 3 over 5 square root of 50 minus 2 over 3 square root of 18. I can write square root of 8 as 2 square root of 2, or I can write this one as 1 over 2 square root of 4 times square root of 2. 4 times 2 is 8, plus 3 over 5 square root of 25 times square root of 2 minus 2 over 3 square root of 9 times square root of 2. Square root of 4 is 2, so 2 over 2 is 1, so they cancel, so I get square root of 2 here. Square root of 25 is 5, divided by 5 is 1, so I get plus 3 square root of 2. Square root of 9 is 3, divided by 3 gives me 1, so I get negative 2 square root of 2. Now these are all like terms, so I get square root of 2 plus 3 square root of 2 gives me 4 square root of 2 minus 2 square root of 2 gives me 2 square root of 2. The next one is 10 minus 3 square root of 75 over 5. I can write this one as 10 minus 3 square root of 25 times square root of 3 over 5, which is equal to square root of 25 is 5, so I get 10 minus 15 square root of 3 over 5. I can divide every term by 5. This one becomes 2, this one becomes 3, and this one becomes 1. So the final answer is 2 minus 3 square root of 3. The next one is 5 square root of 3 over 2 square root of 8 plus square root of 3 divided by square root of 32. I can write this one as 5 square root of 3 over 2 square root of 4 times square root of 2 plus square root of 3 divided by square root of 32. I can write as square root of 16 times square root of 2. Since 16 times 2 is going to give me 32. If I simplify this one, it's going to become 5 square root of 3 over square root of 4 is 2, so 2 times 2 is 4, so 4 square root of 2 plus square root of 3 divided by square root of 16 is 4, so it's 4 square root of 2. Now, the denominators are the same, so the answer is 5 square root of 3 plus square root of 3 is 6 square root of 3 over 4 square root of 2. Now, since we do not want any radical in the denominator, I'm going to multiply numerator and denominator by square root of 2. So I get 6 square root of 3 times square root of 2 is 6 square root of 6 over square root of 2 times square root of 2 is 2 times 4 is 8. I can divide numerator and denominator by 2. I get 3 here, I get 4 here. So my final answer is 3 square root of 6 over 4. The next question says solve the following system of equations graphically. The first one is the vertex form of a quadratic function, and the next one is a horizontal line. The horizontal line is easy to plot. It's going to be a line which goes through the point -4. Now for quadratic, we can see that the vertex is at -3 and 5. So -3 and 5 is going to be a point. This is -3, so 5 is here, so it's going to be here. Now, since the leading coefficient is -1, it opens downward. Now we need to find a few points here. The first point we are going to find is, let's say, the y-intercept. The y-intercept is going to be when x is 0. When x is 0, f of 0 becomes -0 plus 3 squared plus 5, which is -9 plus 5, which is -4. So we know that it's going to pass through this point. So our parabola goes like this one, and since, remember that the axis of symmetry which goes through the vertex is given by the equation x is equal to -3, this point which is on the right hand side is going to have a mirror of it on the left hand side. So the left hand side is going to be somewhere around here. So this is the other point that the graph is going to have. Now this is one point of intersection which is going to be 0 and -4, and the other one is going to be -6 and -4. So the point of intersections are 0, -4, and -6 and -4. The next question says, what does a family of parabolas mean? By definition, a family of parabola means that they have the same x-intercepts or zeros. The leading coefficient A does not matter here. It's going to be a variable, but the zeros are going to be the same, the x-intercepts, meaning that the equation becomes like this, where R and S are the zeros. The next question, we have an auto parts store which currently sells 300 spark plugs package each week at a price of $6.40. So this means that our revenue is going to be the numbers sold times the price per package. If there is no change in the price, we know that we are going to sell 300 at $6.4 each. But we are deciding to decrease the price, to reduce the price of a package by 10 cents. And we know that every time we lower the price by 10 cents, we sell 5 more packages. So let X be number of times price per package is reduced by 10 cents, 0.1. So this means that for every time we reduce by 10 cents, we are going to have 5 more customers. So 300 plus 5x times 6.4 minus 0.1x. Now we want to maximize R. So this means that we have to find the vertex of a quadratic function. I'm going to expand this one, and when you expand it, we are going to get minus 0.5x squared plus 2x plus 1920. Now, if you look at this quadratic equation, the leading coefficient is negative 0.5, so this means the parabola opens downward, so our vertex is really a maximum. To find the coordinate of the vertex, I'm going to use a shortcut, so I'm going to say v sub x is minus b, which is 2, divided by 2a, 2 times negative 0.5, which is going to give me 2. This means that if we lower the price 2 times, meaning by 20 cents, we are going to maximize the revenue. Now the question is, what price is the question? Since we have to decrease the price twice, this means that the new price is 6.40 minus 0.1 times 2, which is going to be 6.20. That's the new price of a package. The next question says, subtracting twice 2 times a number from its square equals 26. You're supposed to find the possible values of the number in simplest radical form. So let the number be x. So let the number be x. Then this statement says subtracting twice a number from its square. So x squared minus twice the number is equal to 26. Or x squared minus 2x minus 26 is equal to 0. This is a quadratic function. To solve it, I'm going to use quadratic formula. I know that discriminant is b squared is negative 2 squared, which is 4, minus 4 times a times c, which is going to give me 108 greater than 0, so 2 values here, and the values are x1 and 2, is minus b is 2 plus or minus square root of 108 divided by 2a, which is 2. Now, I can write 108 as square root of 4 times square root of 9 times square root of 3, because 4 times 9 times 3 gives me 108 divided by 2. Now this becomes 2 plus or minus. Square root of 4 is 2, square root of 9 is 3, so 2 times 3 is 6, square root of 3 over 2. I can divide everything by 2, so this becomes 1, this becomes 1, this becomes 3. So the answer becomes 1 plus or minus 3 square root of 3. So the two numbers are 1 plus 3 square root of 3 and 1 minus 3 square root of 3. The next question, we have a baseball which follows a path given by this equation. Now a boy shoots at the baseball with a paintball gun that follows this function. We want to know when the paintball is going to hit the baseball. Whenever they hit, it means that their height has to be equal, so this means that negative 5t squared plus 16t plus 15 has to be equal to 3t plus 3. Moving this to the left and simplifying, we get negative 5t squared plus 13t plus 12 is equal to 0. This is a quadratic equation. To solve, we use quadratic formula. Our discriminant, d, is b squared, 13 squared, minus 4ac, which is going to give us 409, which is greater than 0, so we have 2 zeros here. To find the zeros, or the time, we know that it's minus b, which is minus 13, plus or minus square root of 409 divided by 2a, which is negative 10, 2 times negative 5. Now, square root of 409 is about 20.2. So, there are two answers. One, if we add 20.2 to negative 13 divided by negative 10, we get negative 0.72, which we cannot accept because time can't be negative. If we use the negative one, meaning negative 13 minus 20.2 divided by negative 10, we get 3.32 seconds, which we can accept. Now, the next question says, determine at what height the baseball will be when it gets hit by the paintball. I can use either one of those equations, this one or this one, and evaluate at the time 3.32 seconds. The easiest one is the linear one, so I'm going to say g of 3.32 is 3 times 3.32 plus 3 is going to give me 12.96 meters. Now the next question is asking us, determine the maximum height that the baseball will reach to the nearest tenth of a meter. Now, we know that h of t for the baseball is given by the equation negative 5t squared plus 16t plus 15. To find the maximum height, I have to find the vertex here. I use the shortcut, so I'm going to say Vt is minus b over 2a, which is negative 10. This is going to give me 1.6 seconds. Now, to find the maximum height, I have to find v of h, which is going to be negative 5 times 1.6 squared plus 16 times 1.6 plus 15. If we simplify this one, we get 27.8 meters.